Hi everyone, welcome back to Daily Lead Code problem. So today we are going to solve problem number 2901, which is longest unequal adjacent groups subsequence 2. So before watching this video, maybe you can watch the yesterday video, which was longest unequal adjacent group subsequence 1, so that you can get clear idea about that. So let's break down the description of the problem. So basically you are given words and groups. So uh, each word is belongs to corresponding groups of that same index, right? So here you can see B is corresponding to group 1, DAB is corresponding to group 2, and CAB is corresponding to group 2, right? So now here we have to find the longest subsequence, right? So here actually out of the three elements, if we see BAB, DAB, CAB, so we have to find the longest subsequence such that this the groups would be different. Like let's say if we can select BAB and DAB, right? So the group will be 1 and 2. These are different. We can't select DAB and CAB because the group are same 2 and 2. So this is the first condition, right? Now the second condition, they have introduced one extra condition from yesterday problem, which is Hamming distance should be 1. So what is Hamming distance? So basically, let's say if you consider two characters, for example, from here, let's say we have a solution. One solution is BAB and DAB because they have different group, right? 1 and 2. So if we consider BAB and DAB, so look, between these two string, they have only one character difference, that is B and D. Rest of the character are same. So that's why the Hamming distance is 1. Okay, so let's try to solve the problem. So this was the condition. So how we can approach this problem is that so here we are trying to find the longest subsequence with these two condition. So you might have heard about the problem related to longest increasing subsequence. If you have not heard about longest increasing subsequence, first of all, I will suggest to solve that problem, because this problem is related to that longest increasing subsequence problem. Just the difference is that instead of increasing, here we have to put these two condition, this number 1 and number 2, right? The logic is same. We have to change the logic inside the if condition. So let's get the solution. Okay. So this is the solution, because this is the solution where I have used the DP. So what basically we are doing, first of all, we are calculating the length of the words. Then we are initializing a DP with empty array. So the result of this DP will be like this. You can see, since there are three words for this test case, so three empty array inside a main array. Okay. So we have considered a max length 0 and max index minus 1. I will tell later on about this. So in basically in longest increasing subsequence, what we do, we run two loop. That is, one is from 0 to n, and second one is, or you can run from 1 to n, and j is from 0 to I, right? So basically we run two loop. One is I till the number of words, and one we run j loop till the I, right? So we check previous, so that we can compare the previous word with the next word. So now, okay, and here we are, what we are doing, since in every DP we are pushing these words I, because every word is, you can say, longest subsequence of itself, right? So every word in that words array is longest subsequence of itself. That's why we are putting these words I in the DP initially, and after that we are running the loop from 0 to I, and we are checking all those conditions which is mentioned in this problem. The first one is like group should not be difference corresponding to each word, right? So that is was the first condition. Now second is the word length should be same. So whatever words we are considering, because here it is given strings in words may be unequal in length, right? Here it is mentioned. So we also need to check that condition. And third condition is Hamming distance. So Hamming distance between these two words should be equal to 1, right? So I have written a function here, Hamming distance. So we are taking two word and basically we are running the loop till one word length, and we are checking each character. So, and if the character is not equal, we are incrementing one counter, and we are returning that distance, right? So in here we are checking if the distance is 1 or not. So if it is 1, it means it fulfill our criteria. And also we are yeah, and also we are doing this dp of I dot length, it should be less than dp of j dot length plus 1 uh, for increasing subsequence, I mean for this longest subsequence. So this logic is, you can only get this logic if you solve the problem related to longest increasing subsequence, right? So there basically we use dp, and we check this condition if like dp of I should be less than dp of j plus 1. um, so that was the condition here. And after that what we are doing, we are checking, we are calculating the max length. So here we are checking if dp of I dot length is greater than max length. So initially we have initialized our max length with 0, and here we are checking that condition. So if it is greater dp of I dot length, so we are initializing that to max length, and also we are tracking the index as I, the index of the max length, right? So that we can get the corresponding value of the array. So now since we have since this at the end, this max index point to the array having the max length, so our final solution will be dp of max index, right? So let's try to run this solution. Yeah, so it is accepted, and I will try to submit it. So it is submitted as well. And one thing I forgot to mention, what is the time and space complexity. So here we are using two loop, right? Two loop we were using, to the time will be n square, and also we are using this loop, right? So this will Hamming distance we are calculating inside this nested loop. So it will take let's say the length of word is, let's say w, or let's say L. So the time complexity will be n square per two loop into L, for since we are also comparing words, right? I'm running the loop till word. And after that we have to find the space complexity. So here we are calculating, I mean initializing dp with array, right? So it will be of length n, and in each array we'll be putting the words, right, which is of length, let's say L. So the space complexity will be n into L, right? So yeah, this is the time and space complexity. Hope you like this logic, and drop me a comment if you have if you solve this problem with any other logic than this, so that everyone will know. Yeah, thank you so much. See you tomorrow. Bye bye.